In a number of training sessions that we've done in the past, we've had a few requests from people to be shown how to use a basic school oscilloscope. So that's what we intend to do in this short video. I'm going to go through all the functions of a standard lab oscilloscope, show you what they do and how to connect a signal generator to obtain a nice trace on your scope. Now they all look slightly different, but the general functions are going to be the same. You'll find the same knobs, just might be in slightly different places. And they're all going to have these three sections here. You're going to have a horizontal adjust section that includes the time base, and that controls how quickly the trace moves across the screen. So at the moment it's moving across quite slowly. If I adjust this, I can speed that up or slow it right down. You're going to have a vertical adjust section, which on this one contains two inputs. Your scope may just have one input, in which case you'll only have one set of the knobs, or it might have two like this, in which case there'll be two separate controls and a selector switch that switches between them. So at the moment I'm switched onto channel 1, which means it's this set of controls here that I'm looking at, and if I adjust the vertical position I can move the trace up and down on the screen. If I switch this to channel 2, I've now got control of this side and I can move the trace up and down on the screen. This set of controls is going to do nothing because it's not switched in. Back onto channel 1, and there we go. The final section is the triggering section on the scope. This really controls how you're going to get your trace to stay nice and steady on the screen. Most of the time in schools all you're going to want to do is leave this set to auto, and if you've got a dual beam scope like this, the source wants to be on whichever channel you're using. So if you're using channel 1, switch onto channel 1 and switch onto channel 2 if you're using channel 2. So the first thing to look at if you're struggling to get a steady trace is your trigger on the same channel as your input. So that's setting up your scope and the main functions. Let's go through from the start then, from a first switch on of your scope. Often when you turn your scope on, you'll see the lights on, the power's there, and you're getting nothing on the screen. What's the first thing you need to do to try and identify where your trace is? Well, this button here, you're somewhere on your scope, you're going to find this knob labelled intensity or in 10 or something like that. That controls how bright the trace is on the screen, and if that's turned all the way down, you're not going to see anything. So the first thing you want to do is turn that intensity knob all the way up, just in case the trace is on the screen but you can't see it. In this case it's not, so we need to try and find it. So let's switch vertical mode to channel 1 so I know which one I'm controlling, and all I'm going to do is move the vertical position of channel 1 until the trace appears on the screen. There it is. Centre it on the centre line. I can now use a horizontal position to move it into the centre of the screen. Okay, if I turn up the time base there, I'll get a nice solid steady line. And that's channel 1 more or less set up. You can see now if I turn the intensity all the way down how there's no trace on the screen, even though it's right where it should be. Because that's turned down, you can't see it. So it's always worth checking the intensity button there. Now's a good time to focus the beam so you get a nice sharp line rather than a wide horrible one. And that's channel 1 done. If I switch now to channel 2 isn't on the screen, so I need to adjust this vertical position, and there it is. So that's my scope setup and ready to accept the signal. And what I'm going to put in is a 1 kHz sine wave from this signal generator here. And I'm going to put that into channel 1. There it is. And there's nothing on the screen. So in this case the first thing to look at is, are you using the right channel? And I'm not. I've got this set on channel 2, my input's in channel 1, so I'm not going to get anything. Flick it to channel 1 and you can now start to see a trace on the screen. It's clearly too large. It goes off the screen at the bottom and it goes off the screen at the top. So I want to adjust my vertical setting here, my volts per division, and turn that down until I get a trace that fits on the screen. And this is where your triggering section comes in. You can kind of see the trace, but it's moving from left to right, so you want to use the trigger level, make sure it's set on the same channel you're using, make sure it's set on auto, and this level button, just rotate it slowly and you will eventually get a nice steady trace on the screen. You can now use your time per division to open that wave up and get a nice wave on the screen. So there we go. All the numbers on this scope refer to the large squares on the screen. They refer to per division, so it's time per division or volts per division. So the horizontal is set at the moment on 0.5 milliseconds per division. Now I can position this trace so the peak of one wave is on a large marker, and I can count how many big squares across my next wave is. In this instance it's 2 divisions, 2 big squares, about a centimetre across. So that's 2 times 0.5 milliseconds, that's a 1 millisecond time delay from peak to peak. That's the time period of this wave. If you work out the frequency from that, a 1 millisecond time period gives you a 1 kilohertz sine wave, which is exactly what I'm putting in for my signal generator. If we move on now to look at the vertical component, you can see that this encompasses 4 big squares, and my volts per division is set on 1 volt per division. So this is a peak-to-peak voltage of 4 volts. If I adjust this to 2 volts per division, adjust my trigger, it now covers 2 squares, which is still 4 volts at 2 volts per division. So that's setting up your scope to display a basic sine wave from a signal generator. The only thing we haven't looked at yet is this AC, DC and ground setting on the input. It's currently on AC, and if I flick it to DC, not very much happens in this instance, but that's purely because of the input I'm putting in. We'll come back to that in a minute. If I flick it to ground, I get no signal at all, and you never will. The ground setting connects the plates on the scope to ground to 0 volts to allow you to position that line accurately where you want it before flicking it back onto AC or DC, whichever you choose. To give you some idea of what DC does, I'm going to connect a different input, still sinusoidal, but in this case it's going to be a 10 kilohertz sine wave, to channel 2. So if I flick now to channel 2, you can see now my trace has changed to channel 2, trigger source channel 2, adjust the trigger level until I get a nice stationary wave. Let's increase the time base. Let's decrease the time base. And there we go. So that's my 10 kilohertz wave. At the moment, that's on the AC setting, and I'm getting a lovely wave that's above and below the centre line. If I suddenly flick this to DC, it vanishes. And we'll see why in a second. If I turn the volts per division all the way down, so that's now on 1 volt per division, this input has a 1 volt DC offset. So there's a 1 volt DC offset, and then the sine wave is on top of that. If I want to see this sine wave in more detail, I'll increase my volts per division and it moves up the screen. If I continue to do so, it ends up completely off the screen, you can't see it. So the AC setting here takes away all that DC offset and brings the trace down to the centre of the scope. Unless you're actually measuring DC, the AC setting is probably the best bet for you. The last thing to mention really is the benefit of having a dual beam scope like this is on the mode selector button there will be a dual option which will allow you to display both waves at once. So there you can see I've got the input from channel 2 and the input from channel 1 on the screen at the same time. Triggering on channel 1, let's try that. By adjusting the frequency, I'll be able to get both waves stationary on the screen at once. And there you go. Okay, the introduction to the simple school oscilloscope.